back, 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 back.
Students, today is a topic about project network, project scheduling. So before we move into the content, I would like to ask a question just by intuition. What do you think a project network is? So that's something coming from a project planning and defining, and the project network is part of the project management. Lamba, do you want to answer what project network is?
Yes, ma'am. 1 second.
Okay.
Maybe like a diagram that shows
Very
what you have
good. It is a diagram. If you
Ma'am,
use
it's a graph that displays the order in which the project activities are to be completed.
very good. It is basically visually it's a diagram, but content-wise there'll be many things involved. Basically cover all the elements, activities, schedules, time scale of a project. So it's very easily to visualize where the project from and where the project will go forward to.
It's
And
like a
also,
structure.
yeah, it's also like a mind map as well, but every detail of the diagram need to be quite specific. So that's a project network, which is built on many things we have studied previously. So in terms of developing the project network, is a tool basically with project management, including planning, scheduling, monitoring, and defining, etc. All these activities. This network needs to be developed from the information collected from the previous work, such as WBS, okay, and use graphic flow chart to depict the project plan. The network shows the project activities, the time scales in great details, and in logic consequences as well, and also shows the relationship between different activities and define when the next task should be completed or should start based on previous completion of other tasks. So in most cases, the times for the activity to start and to finish, along with the longest path through the next work. So that's the project network. And in the meantime, this network helps to assess the feasibility of the planned project, and then understand the estimate and the completion date of those different tasks under the whole project. Also help to identify resource related issues and activities as well. So to understand where, how much, what kind of resources should be used at different sectors, and also calculate when costs will be incurred. Overall, this will help the coordination and also successful completion of this project, and motivate staff and the project team for them to understand the overall picture and with transparency in terms of the whole project progress. So that's the point of the project. Also, the importance of a project network. Managers often use this to deliver projects on time as one of the biggest challenges. So this had been happened in different types of projects previously. So project management developed this technique, these strategies to overcome this time-related project completion issue. Time has the least amount of flexibility for many of the projects. Okay, it passes no matter what happens on a project. So in order to make sure that this one element is very well disciplined, then give the project a well predefined and planned scope that will help really better control of this element. Individual work styles and cultural differences could exist, and may also cause schedule conflicts. So predetermined schedules can overcome these barriers as well. And when modern projects also involve quite a lot of international expertise across different countries and across different continents. Geographically, this could cause quite a lot of difficulties in terms of making sure everyone on time. Okay, so just imagine that you have a mega project, but people involved in the project in like 20 countries. That would be a huge undertaking in terms of finishing the project as well as coordinating between different groups. So that's the importance of a project. I want to show you some of the examples. For example, this is two projects that had some issues. Okay, one is the 2002 Salt Lake City Winter Olympic Games. This had been well planned. Okay, all the Olympics mega project needs to be detailed planned. So, but many articles were written before the opening ceremony, predicting that facility will not be ready in time. And the Greek even made fun of the and this was in 2004 Olympic, made fun of the critic by having construction workers pretend to still be working as the ceremony began. Okay, so and in 2014 there was a Winter Olympic Games in Russia, and all three Olympic Games suffered different types of and extents of scheduling failure, basically. So as the Asian Olympic Games shows that people were still working, okay, still working on something before even the Olympic was starting. So do the other American and Russian ones. Okay, this is just one example. If time is not well followed, then there are other losses. Financial losses would follow for sure. Okay, and also there are also damages to countries' reputation, image of this country, etc. Okay, they can be even more beyond the economic loss, become political or geopolitical. Okay, so these are some of the examples here. Examples of activities. One Lambda mentioned the diagram. This would be one of the diagrams. Okay, it would be looking like this. So there is a starting time, and in the middle there are different activities with specified timing, length, types of activity, etc., and resources needed, and finishing time is specified. That is very complex because a lot of times some would be the timing would be overlapping. So project A starts and then project B would not be able to start until project A finish. Sometimes even have to wait until 2-3 projects finish. And some projects would finish quicker or some later. So all this can determine the overall progress. So this is just an example of an activity network. In terms of next topic, scheduling. So scheduling is part of this project planning and network creating, basically. So they go hand in hand. So when the network is established, all the detailed schedules could be created as well. So basically, time is a natural way of stopping everything happening at once. Having worked out a method of doing the project and identify the task to be finished, assess the time needed to do each task. That's scheduling. That's basically the content of the diagram. And resources, dates, times need to be allocated to different nodes on the different boxes, basically on the diagram. And they're so interconnected, and that makes this scheduling quite difficult. Even just give you another example, even when we are doing timetabling in teaching, because in a term you got a lot of tutors and lectures, and you got a lot of students with different modules and lessons. For that, if you got 20 modules to be taught in a term, and different staff have different schedules, students have different requirements, then it became really highly complex. Okay. Unlike alone something like Olympic game. So this become very important. Sometimes people using software actually. The end of this session, I will introduce some of the modern software that can help facilitate scheduling. Okay, when there are so many uncertainties and variables involved. How is a project scheduled? So we know schedule is about allocating different resources. So we want to see how this can be done. The individual, the big picture is the individual work items called tasks or activities required to complete together in order to finish the whole project. But for each task, you might want to know specific features for each task. Many bigger projects would involve hundreds, even thousands of tasks. But for each one, with planning and estimation, they need to be relatively clear. The duration of the projects, the content of the project, the resource constraints, and task dependency. Okay, other tasks would depending on this task. If you enter resource, task, schedule, all those information, they can be further refined according to the workflow as well. So there are more subtopics, sub-information involved in different tasks. So the basic principles of project scheduling is about creating deliverable-based project schedules. So deliverable things, the tasks we mentioned in last week's topic, make sure things are deliverable, measurable, and achievable in different planning and scheduling, and also has to determine the appropriate level of details. Okay, it's not easy because details are very specific. But when project is very long and extensive, go to details is not very possible in quite a lot of situations. And also changes could happen. So even if this month something being made, but next month things could be changed, revised. But then in terms of details, projects also need certain details. It's not like just give a big sketch and then people can start working on it. In certain situation, very details are close details are really needed in order to instruct the job for people to get to start on it. But this needs to be well balanced by the project management. Implementing a regular status update and report process, and regularly review and update the schedule. So those are some of the basics in project scheduling. In terms of project strategies, normally there are some tools and tactics we will mention later. This is one of the strategies that have been used by quite a lot of manufacturer work in the US. So hence, see this word comes from, because now we use this a lot. Post-it notes. This little paper has been used by a lot of project management. They look like a little box. So if people are doing brainstorming, they write different ideas, and if they do project scheduling, they put ideas into different post-it notes and put them together as a network. That can be a draft of a project logic, basically, and visually present. So to summarize, the basics of a project rules are time allocation, which means to allocate number of work units to different tasks in terms of person, timing, and some starting and ending times. And the next one is effort validation, ensure no more than the allocated number of people are allocated at any given time. So those two things are highly detailed actually. And next one, define the responsibilities. So each box, each post-it note should contain well-defined responsibilities. So if you are doing a group work and you have defined responsibilities, for example, someone would research, someone would do the PPT design, or someone would do the writing, etc. So you give different people specific tasks in the group project, and also define outcomes needed to be quite clear as well. Basically, if it's a group project, for example, in 2 weeks' time, then what you want to achieve, you might not able to complete the whole project, but then 2 weeks time you might need to be able to finish 3 sections, for example, and have a vision what you're going to do in the next 3 weeks time. So that's kind of a defining outcome. And similarly, defining milestones. These are very important as well for projects that could last for years. So each milestone needed to be completed, then the next one can be finished. I think it's quite similar to you're completing midterm, end term, or 2/3 term learning. So that's kind of a milestone. So for first outcome completion, you might learn and some basic comprehension, and for second, you might go deeper into this topic, and for the final one, you're going to do some applied practice. So that's milestone. Okay, that's really giving you the really refined idea what each stage people need to achieve, basically. With this, different specific qualitative or quantitative measurements or deliverables could be defined. Deliverable-based schedules. Deliverables are products produced by a project. All projects have deliverables, and activities are performed by team members in order to create deliverables. Deliverables almost like outcomes, but because they're specific, relates to different individual tasks, so they can be called deliverables. But when you get the whole project finished, that would be called outcome. Activities are different actions that are associated with those deliverables, called the WBS we studied previously. So WBS are quite specific, basically break down the big task into manageable small pieces. So they're called WBS. This would be used for scheduling. Okay, so WBS might not be specific in terms of resource allocation and timing, but it breaks down the tasks into different steps. And then if it's further refined, it will become schedules, because schedule would relate to timing. Okay, WBS is more likely relates to the breakdown of the overall task. Earlier mentioned appropriate level of details. The best project schedules are those which contain all of the required information and nothing more. So this is a good criteria. The best project schedules are very sharply focused on the things the project need to finish, nothing else. There must be sufficient details to accurately track and manage the project activities and the deliverables as well. There must not be so much details that the schedule become unmanageable. So that's the key point. So putting essential things like things unavoidable must do, than putting things avoidable, things that you don't need to use or you don't need to do or you can be omitted, then that's a good project. Okay, so this criteria is quite a good benchmark for project management when they assess the schedule and then knows where to be focused and where you can which part can be avoided. Next topic. So earlier mentioned that there are schedules need to be regularly updated as well, simply because projects are very complex and long-term sometimes. So many things are uncertain, and there are a lot of risks associated with project activities, as well as some uncertainties. So regular revision, regular feedback, and keep the communication channel open, as well as very spontaneous, very timely adjustment. Those are key part of the scheduling as well. So keep the schedule very focused and detailed, as well as the schedule needs to be adaptable and flexible. So that's a regular update, including reviewing and adjustment. So the schedule is not rigid and static, but dynamic and adaptive. Also a good sign of a very good project scheduling. Overall, the project management process has a couple of steps. Okay, individual ones could be different, but overall, this would be good guideline to project time management. So at the beginning is planning, schedule management and defining activities and sequencing as well. There are quite a lot of techniques can be used, and estimating activity resources. So resources relates to human resources, financial resources, data resources, or time resources. Okay, and time also relates to next one, estimating durations of each activities, then developing the schedule, and finally controlling and monitoring the schedule. This is a illustration. Okay, this actually come from using IBM approach to illustrate a project. A project basically has a very structured network. Basically, this is based on deliverables. So there are 5 levels. Basically, level 1 is the project, and level 2 deliverables, and level 3 components, level 4 work package. So groups of tasks needed to produce the component. Okay, so for example, in software components, you have to complete review requirements, outline design, detail design, code software, test software. All these things need to be completed in order to produce software components. So these are tasks. This is a breakdown, WBS. Okay, this is not schedule yet, because we don't know the time. We only know the components. And sometimes this can be a schedule project plan. This is a chart that shows the different tasks, different people involved, as well as the duration, starting and finishing time. So this is a simple project plan. It tells basically the four W's: who is doing it, what, when, maybe why. Okay, so this could be comparing to this one. The second one would be a schedule. So this is this one, the schedule. Sorry, just slow. Because it answers the 4 W's or 3 W's: who, what, when questions. Okay, and adding the time estimation to the breakdown of the tasks. So far we just introduced schedules and the importance and purposes of schedules. Here are 2 technical terms. These are scheduling tools. So we want to see how different tools can help project management teams to develop logic, reasonable and efficient project schedules. So there are 2 prominent tools. One is called critical path method. Okay, one is called program evaluation review technique. These are tools to develop critical paths and also establish very logical and most likely time estimate, as well as calculate different boundaries of time, time windows, etc., beginning time and closing time, and sequences of different tasks. So these tools are widely used tools, and they have been, so these 2 tools just would look like this. Okay, so these 2 tools I explain them again. The critical path method is a project management tool used to plan, schedule, and control complex projects. Okay, so you can see here, it was developed during 1950s. The technique was developed and used in a lot of very big projects in the US. Okay, so CPM, you can see CPM in DuPont developed it. And PERT developed in association with the polarized missile project. So these are that at that time when projects were getting bigger and bigger and very critical, people getting more in-depth understanding into how to manage projects. So these 2 methods were developed during that time in order to manage. Basically, they are used to plan, schedule, and control complex projects or mega projects. We will illustrate how to use CPM using an example. Okay, later. I just give you some key features of these 2 things. So the sequences of tasks in, for example, CPM It's called critical path, and it helps project managers to identify which tasks are critical. Okay, when people are involved in very big projects, sometimes they can go different paths with different starting and ending time. But however, which combination is the best, quickest, and also most resource saving path, that could be illustrated in the network diagram, okay, with some calculations. So these two methods are used to estimate project duration and also allocate project resources efficiently. PERT involves creating a project network diagram that includes all the tasks, durations, and dependencies. It's similar to CPM, but it's widely used when durations, starting or ending times are not very certain, okay, highly uncertain. As well as it's using diagram to develop a calculation to identify the most efficient path in the project allocation and management. So here I have got, so this network tools basically used to highlight these things: concept, activity, relationship, successor, and events. So this would be illustrated in those diagrams. So they are coded, but when they are decoded, you will see what DOA, DOC mean, and which each length of the lines, it will show the duration of the path, and some very critical paths, like most efficient paths, could be identified using this diagram. So here is an activity on ARC illustration. So for example, task A starts. After task A finishes, task B and C could start. And next two could start after B or C finishes. And there may be some event being created, not realistic events, but will help maintain this circuit, maintain this path actually. So they call dummy nodes. And here is another illustration. When two or more activities share the same precedence, then not all the precedents are shared. So anyway, just showing you the relationship between different nodes, and each node represents a task. There are some technical terms. Okay, some are, for example, first node, or some are dummy nodes. And another key element when doing the estimation is the timing. So earlier starting time is called ES. Earliest finishing time is called EF. Okay, these are just codes to represent the timing. ES, EF, LF, LS. This should all be included and specified in this chart, in this diagram. And when it's using method to estimate, there are actually two methods. One is forward pass, one is backward pass. So forward, so starting from A and move down to the pass, give each task a duration, as well as the early starting and early finishing time. Then bit by bit can move to the final completion time. And when all the timings are added up, that would be the completion time for this whole project. Okay, these are some terminologies. We will look at one example later. Slack time, using slack time is the slack time for an activity is the difference between the earlier and the latest start time, or earlier or latest finish time. And this is slack time is the calculation. Okay, a calculation that can determine the critical path. The critical path is defined by the slack time, basically. And slack time is calculated by finding the difference between earliest ES and LS, or EF and LF, basically. Just to summarize the purposes of these two tools, and we can see some examples. So the key point doing CPM analysis of network since all activities must be completed to complete the whole project, so the length of the critical path is also needed to be the shortest allowable for completion of the project. So CPM is found the shortest one. There are probably a couple of passes in real life when it's a very complex project. So the shortest one is the criteria that CPM want to identify. So if the project is to be completed in the shortest time, all activities on the critical path must be started as soon as possible. So it's quite easy to understand mathematically as well. So all things, when they are very vague and specific, then you don't get the overall timing easily because it's not specific. But when you get specific timing and knows the dependency of each tasks, then you can get the overall timing quite accurately. If the project has to be completed ahead of the schedule, then the time required for at least one of the critical activities must be reduced. And further, any delay in completing the critical activities will increase the project durations. Okay, so each element on the chain is very crucial in maintaining the project on track, as well as maintaining the whole project completing on time. Okay, if any one element on the chain has problem, then it can have a ripple effect on the whole project. That's the key point of this CPM as well as PRT, two tools to find the shortest critical path. To give you some more information, the activity which does not lie on the critical path is called non-critical activities. Okay, so that can, from the minimalism principle, that's something that can be considered using other way to be replaced because they're non-critical. These non-critical activities may have some slack time. Means the difference between early starting, early finishing, and early starting, latest finishing. About a critical activity. A critical activity would have no slack time. Okay, so that's quite a good criteria to see if a path should be considered or not. A critical activity, a good activity that can ensure project finish on time or using resources very efficiently, that would be some activity has no slack time. To reduce the overall project time, that critical activity can do it. It would require more resources sometimes to reduce the time taken by the critical activity to complete. So anyway, these are the meaning of slack time and critical activity, but this message also give you the indication that critical time could be done with some cost. Okay, so either with actual resources or actual people's working hour or actual finance. Okay, if people want to quickly finish something, then they have to undertake the critical activity instead to wait to save some money. Okay, that's the balance that the management needed to consider. I think this could be considered in last week's exercise. Remember the couple building their own houses or renovate their house. So sometimes they have to they can do the job themselves in order to save money. But then if you use the critical time principle to thinking about that cases, then that can be something the couple has spare time. So the time is not the critical point. Resource is the critical point. So saving resource prioritize over timing element, then they can do the work themselves. But if they want to do the work quickly, then they have to spend money on those things. So these are just some principles of earliest time or latest time or slack time, etc. Steps in PERT is relatively similar actually, like identify tasks, determine the sequence of the activities, and then build up the network diagram, estimate time, duration of these different activities and determine the critical path.
Can you explain that what is the critical path again?
Okay, I will explain this, but before this, we have a look at a video. Okay, this
Yes, ma'am. You
Welcome
can
to
go.
this video on finding the critical path
is good.
on a project network. I'll be working with this schedule for a project. I'll be constructing a project network, doing forward and backward passes, determining the project completion time, calculating slack values, and finally stating the critical path. I will be using this node convention here, as you will find in Quantitative Methods for Business by Anderson, Sweeney, and Williams. A here is the activity being described, and T represents the expected activity duration or time. ES is the earliest time the activity can start. EF is the earliest finish time. LS is the latest start time. And LF is the latest finish time without extending the minimum completion time of the project. I usually like to start with a sketch to make it easier when drawing the full network. Activities A and B have no predecessors, so they can begin as start. Activity C needs A to be completed before it can start. D needs both A and B completed. E needs D, F needs C and E, and G depends on E. Since F and G have no successors, they go to finish. So here is the network with the activity nodes displaying the letters and times. So let's do the forward pass. A has no predecessor, so its earliest start time will be 0 or right away. Since it has 7 weeks to be completed, its earliest finish time will be 0 plus 7, which gives 7. B also has an earliest start time of 0, and with an activity time of 9, it will have an earliest finish time of 9. Now, C needs A to be completed before it can start. Since the earliest finish time for A is 7, then the earliest time C can start is 7. And with an activity time of 12 weeks, C will have an earliest finish time of 12 plus 7, which gives 19. D, on the other hand, needs A and B to finish before it can start. Since the earliest finish time for A and B are 7 and 9 respectively, and D needs both of them to finish in order to start, then the earliest time D can start is 9. In other words, the highest of the earliest finish times preceding an activity will be the activity's earliest start time. So D finishes at 8 plus 9, which gives 17. E here has only one predecessor D, and so can start at 17 and finish earliest at 26. F has predecessors C and E. Since the higher earliest finish time is 26, F can start earliest at 26 and finish at 32. G also can start earliest at 26, since it has only one predecessor E, and G can finish earliest at 26 plus 5, which gives 31. Note here that although G is the last letter, it doesn't have the highest earliest finish time because F has 32, so we say that the project's completion time is 32 weeks. In essence, the project's completion time is the highest of the earliest finish times at the finish node. Now,
Okay, student, this is a forward pass. Okay, and then based on this estimation, it's 32 weeks. Do you follow this part about this video? Okay, it will use another
now
pass.
let's do the backward pass. Since the project completion time is 32 weeks, the latest finish times for the activities at the finish node, F and G, has to be 32. That is, F and G cannot be completed in longer than 32 weeks. Next, we obtain the latest start times by subtracting the activity times from the latest finish times. For G, the latest start time will be 32 minus 5 to give 27. For F, the latest start time will be 32 minus 6, and that gives 26. Now, E has two successors, F and G. The latest start times are 26 and 27 respectively. As a result, the latest time E has to finish has to be 26 in order for F to start. In essence, when doing backward pass, the latest finish time of an activity must be the minimum of the latest start times of its successors. Thus, the latest start time for E will be 26 minus 9, which gives 17. Now, D has only one successor, E. So the latest finish time for D will be the latest start time for E, which is 17. And the latest start time will be 17 minus 8, which gives 9 for D. Activity C has one successor, F. Therefore, the latest finish will be 26 for C, and latest start will be 14. A has two successors, C and D. The minimum of their latest starts is 9. So the latest finish for A will be 9, and its latest start will be 2. Activity B has one successor, D, with latest start of 9. So the latest finish for B will be 9, and its latest start will be 0. The backward pass is now complete. Now, slack for an activity is defined as how long the activity can be delayed without extending or increasing the project's completion time. And it is calculated as LS minus ES or LF minus EF. So the slack for A will be 2 minus 0 or 9 minus 7, which will be 2. The slack for B will then be 0. For C, it will be 7. For D, 0. For E, 0. For F, 0. And for G, 1. Note, for example, that activity C can begin anytime between week 7 and 14, and it can finish anytime between 19 and 26. Thus, C can be delayed for up to 7 weeks, and the project will still be completed in week 32. Activities B, D, E, and F, on the other hand, cannot be delayed at all without extending the project's completion time. So, for example, if D is delayed by 2 weeks, then the project completion time will be extended by 2 weeks as well, from 32 to 34. The activities with zero slack are called critical activities, and they form the critical path, which is the longest path in the network. So the critical path here is B, D, E, F. And that's it for this video. Thanks for watching.
Do you have any questions?
No, ma'am, now it's clear.
Yeah, basically,
Ma'am, I wanted the name of the video.
the video is here. Lamba is here in the PPT. Okay, there is another video which is also very good. So
Okay, we
basically,
can watch.
can you see the two video address?
Yes, ma'am.
Okay. So watch another video at home. Okay, the other one is very good as well. So basically, the critical path is numerically expressed based on early starting time, early finishing time, and the differences between the two times, LS and ES, EF, LS, EF. Anyway, there's so many small number, but only arithmetic. They're not complex calculation. They just need to remember where to put those numbers. But this is quite efficient way to identify which path is the most efficient way, can reduce wastage in the resources and help you to get to the destination, to the outcome very quickly. If you change anything in the path on the node, the whole project will change. Okay, if you change things slightly on the other activities, like non-slack, non-critical activity, then it doesn't matter. If you delay 1 or 2 days in that non-critical ones, that not that bad actually. But if you pick up the critical one and you delay, that can have ripple effect to the overall project. So this is the critical path. But similarly, PRT actually is quite similar as well. It's just the timing is much more uncertain. Okay, can be estimation rather than very highly specific durations. Network completion process. Again, just repeating the video. I just want to summarize the differences of these two techniques. Okay, so for example, the advantages of a PRT, they have a quite specific way to predict the completion time, but they use probability a lot. Okay, so before specific time, and also critical path activities that as well as identified, but can be based on estimations. Similar to say CPM, it has the duration earlier starting time, earlier finishing time, etc. But PERT has limitations. For example, it can become so complex. Okay, in this one you only see 3 paths, but real big projects can be highly complex. The network charts can be very large and very extensive. When you're calculating the time, it became very complex. Even this video, this one has got 2 numbers on top, 2 numbers on bottom in each box. So that basically 4 numbers, it can quite easily make a mistake actually when you get hundreds of boxes. The logic is simple, but it's very prone to making mistakes when you're doing a calculation. Need someone like accountant attitude, really sit there like doing embroidery almost when you get hundreds of boxes. And also updating of the project can be time consuming and it can be quite costly as well. And some other, so costs are estimated, time estimated, but some other qualitative factors might be overlooked. Okay, that's the limitation of this PERT. Comparing to CPM and PERT, CPM work with fixed decision making, fixed timing, so relatively certain. Okay, but the other one is probabilistic time. CPR is useful for repetitive and non-complex project, and PERT for complex project. CPM includes time cost trade-off, but PERT is retreating to time variable. CPM for construction project, the other for R&D projects. Okay, relatively speaking, these are some of the differences. CPM is relatively simple. PERT can be used for research and development, like the missile development or moon landing. Construction actually relatively certain because it's quite physical, but when it's come to R&D research, there are a lot of uncertain elements involved. So these are the key topics. And so forward pass first, and then backward. And after backward, you can calculate the slack time. Okay, this is a lot of small calculation, but that's the steps. After you calculate the slack time, there is also a note that float can also be calculated. Float is different from slack time. Float is calculated use LF minus ES, and then with different numbers, you can get the float time as well. Practical consideration. Okay. So CPM or PERT are very good, but sometimes there are some practical considerations. For example, in the PERT cases, there are some limitations. For example, they only look into numbers, but these are hugely simplified way to look at a project. Sometimes there can be different logical problems, like project A's predecessor is B and C, and D is need to wait until B and C finish. That can have logical fallacy. Actually, it might not in real life in that specific order. Okay, and sometimes some projects might not be specifically in theory they connected to certain things, but in practical things they might not be well connected. Okay, so for example, if you are building a house, you want to lay carpet, then you have to finish putting the floorboard first. Then someone would think floorboard need to go first and carpet second. But in real life, carpet and the floorboard maybe can go hand in hand, because the floorboard wouldn't be finishing in one day, and the carpet can just quickly on top of the floorboard. I mean, the carpet can be laid when the floorboard is being laid as well. They can go slightly having a time gap, but they can really go hand in hand actually, just slightly one like behind the other one. So anyway, logical discrepancies, activity numbering, computation issues, and then timing issues can all be something that when a network schedule is being planned, and then sometimes needed to address all those issues. This is a logic loop problem. This is an example that shows the automated warehouse ordering pickup system. So this is done by computer actually. This is a computer. This is like a project management software. So as long as you give the tasks sequences, starting, ending time, and duration, then computer will give you the the schedule, the network. When constructing this chart, this network, earlier mentioned some of the terms. Okay, just reiterate some of the terms. So activity is a box. Sometimes there are merger activities. Merger activities are something from here. You can see two or more preceding activity on which it depends. So, for example, B has a merger activity. B is a merger activity because B has got D and C actually. And D can be called. So here you can see bust activity. So something, but the arrow is offset. Okay, so A can be called a bust activity because the A has more than one activity immediately following it. Basically, 3 opportunities depending on A to finish. If A is delayed, then all 3 activities will be delayed. So these are some of these terminologies when doing the schedule diagram. Another rule needed to remember when doing the diagram. So network typically follow from left to right, and activity cannot begin until all preceding connection activities are completed. So that's the theory part. Okay, strictly speaking, is this: if A is not finishing, then B, strictly speaking, B, C, D cannot start completely. Another rule is arrow indicate precedence and flow and can cross over each other. Okay, so in this case, this one hasn't got crossover, but there are some connections. So for example, both B and A will go to D, and then B will go to both D and C. So this just adding complexity to the network. Basically, I think in the video we have got something very complex but not crossover. But bear in mind that the arrows can cross over. Oh, here we got a crossover one. So for this case, you get something. For example, in the final box, you get X and Y goes to Z and AA. So basically, very crossing. This is showing a list of things to do where you complete a task. At the top of the list, you can see it's very linear. Linear is very easy, okay? One step by step, basically. But when it's come to the Y and Z in this chart, Y and Z can occur concurrently or simultaneously, basically, if the project manager wishes. However, it's not necessary condition. For example, pouring a concrete driveway, that would be activity 1, and take place while landscape planting, activity Z, is being accomplished. So I mean, Y and Z can work together. It's like laying the carpet and laying the floorboard. So basically, these 4 activities, X, Z, Y, Z, they are crossing. Okay, activities Y and Z are considered parallel activities. Parallel paths allow concurrent efforts, and X and Y are parallel activities that can take place at the same time. Activity Z and AA are also parallel, but activity Z and AA cannot begin until activity X, Y are both completed. Okay, so this is a crossing example. So basic rules, some other rules like each activity must have a unique identifying number that is greater than any of its predecessors activities. Looping is not allowed. Okay, so remember this. You can't turn a cycle. You have always to go forward to finish it. Condition statements are not allowed. So no on conditional basis. You in a project scheduling, this must be certain. If conditional situation occur, then they can't really produce that schedule because you don't know which way that condition would lead. And use common start and stop node. Okay, so these are some of the rules in drawing the network. I also want to just quickly introduce some of the scheduling software. Okay, I imagine in the 1950s that many of the calculation would be done manually. It's like statistics, you got SPSS at the moment, but then 50 or 60 years ago, all the calculations basically adding up, all the numbers are done manually. So there are quite, if you are project management, you would need to get familiar with some of the commonly used softwares that can be purchased by the organization and professionally use. And then it's like a accountant using Sage software. So these are highly adapted by many big organizations in project management.
It's true that executing projects accurately and timely is not an easy feat, but project scheduling softwares can help. They have the right tools and features to streamline your operations while saving time and money. That's why, in this video, we have gathered 5 of the best project scheduling softwares that will help you to better monitor and manage your project progress without missing any deadline. So, without wasting any more time, let's dive in. Let's start with Run, a real-time project scheduling and resource planning tool that comes with integrated time tracking and powerful forecasting capabilities. This software can keep your employees' information in one place, so you can see everyone's workload, holidays, availability, and utilization rates in real time. With this valuable information, you can plan your future workloads and spot resource conflicts before they occur. You can even adapt to a plan that's been changed. Besides, with detailed analytics and reports, it's easier to compare your team's capacity and utilization metrics by week, month, and quarter. Furthermore, this software has a full API available for building custom integrations. It also integrates with Harvest, Workflow Max, and Clockify to sync your time with Run automatically. Overall, it's a helpful project scheduling software that you can use to get a bird's eye view of all your projects and people to stay on top of your business. At the same time, Run helps you collaborate with coworkers to remain up to date and on the same page with remote teams. When you're picking up a new software, it's common for you to face some difficulties. However, that's not the case with Forecast, an easy-to-use project scheduling software that can save your day. This software has all the right features to ensure your project is appropriately planned and visualized. Not just that, it will also make sure that your team has a smooth sailing experience throughout its duration. Designed to identify bottlenecks and tackle problems in project planning head-on, this tool provides a high-level bird's-eye view of all project activities. You can also add more granular detail as per your needs. Another cherry on top is the auto schedule, which gets your project planned out within a few clicks. This lessens the amount of time you spend scheduling the project and assigning relevant resources to your tasks to a bare minimum. Lastly, the forecast pricing starts from $29, and there is a free 14-day trial available, which is why we highly recommend you to try this software. At number 3, we have Maven Link, an all-in-one tool that not only can schedule your projects, but also can manage projects, accounting, resources, team collaboration, and more. With this project scheduling software, you can make detailed project plans since it offers a multi-level work breakdown structure to define the project by a series of granular tasks and subtasks. To tell you the truth, it's actually more than a project scheduling software where you will find features for resource management, accounting, analytics, and more. Despite the abundance of features, this project scheduling software keeps its user interface pretty straightforward, and we love the minimalistic design too. Besides that, it also offers a unique and effective integration solution called mBridge that simplifies integration between apps like CRM and financial software. Considering all of these goodies, Maven Link can be an ideal choice for you if you want to automate your workflow with your project scheduling software. Next up, we have Resource Management by Smartsheet. It's a high-level project scheduling software to make confident decisions about different things, including finding and scheduling the right people for projects, managing and tracking time spent on projects, and predicting hiring needs in real time. The people page on the software provides a single view into all the people in your organization, including essential details like discipline, role, language, and more. With this, you can quickly find people and schedule the people you need. In the Schedule menu, you can see who's available, what everyone's working on, and who's on vacation. You can also see future plan work to be staffed and assigned to the right people based on matching role, skills, and availability. The Projects menu, on the other hand, gives you a quick look into the scheduled resources for an individual and shows you how you're tracking against projects. Overall, Resource Management by Smartsheet gives managers and executives the visibility to build strong teams and deliver projects on time and budget. Last but not least, let's finish this video with the highly popular Monday.com, another scheduling tool that comes with intuitive collaboration features which are easy to learn and quick to understand. At the same time, it's also highly customizable to help you see the progress and status of your projects at a glance. Most of the project scheduling features on this software is built around the timelines, where you can plan projects, set deadlines, assign team members, break down tasks, and set dependencies. You can also reassign tasks by simply clicking and dragging. Plus, it has different views such as Kanban board, calendar, timeline, Gantt chart, and more to visualize and plan your work more efficiently. Moreover, it integrates seamlessly with different popular apps like Microsoft Excel, Outlook, Teams, Slack, Google Drive, Gmail, Calendar, and the list goes on. In terms of plan and pricing, Monday.com is quite affordable and scalable depending on your needs, making it perfect for both individual and enterprise level businesses. That's why it has made the top of our list today. So, that is all about the best project scheduling software that you can try. Thanks for watching.
Hello, hi.
Man, my battery is dying now. I have to go and find a charging port, so I might shut down for a while. Is that fine?
Yeah, see the quiz, just do the quiz. And also I want to show you that on PPT, there is this exercise here. Look, we
I've
do
seen
this.
the PowerPoint.
Yeah, we do on tutorial, basically draw the critical path, okay?
Okay, ma'am. Thank you.
But do the quiz first, okay? No problem. Thank you very much. I'll see you tomorrow. Sorry, Thursday.
Ma'am, where we can find the quiz?
Hello, students. Can you spend the time doing this quiz?
Where we can find the quiz, ma'am?
I copied the.
I didn't find it on the chat.
Yeah, I copied this on the chat for you. Okay.
I didn't find it.
No, I haven't put on
Oh,
yet.
okay.
Okay, I put it now.
Okay, thank you.
Okay, this is the Quizlet, students. So it's something, it's a flashcard. So can you tell what burst activity is, anyone? Bagdadla, can you answer what this one is? Burst activity. You can check a dictionary, anything, okay? Just answer this flashcard.
Burst activity.
Nice one. Bag. Shizid, can you answer? Not here. Tarek, do you know what burst activity is? Okay.
I think it is an activity that has more than one activity immediately following it.
Very good. Yes. If you click on the card, okay, I don't know who asked me the question because I can't see the flash. So if you click on this phrase bird, it will show you the definition. So this activity has more than one activity connected to it, following it actually. So if A starts, okay, A is cleaning the floor, then B and C can start after A finish, and A is a burst activity. So after cleaning floor, people can mop the floor, or people can lay the carpet. So if this activity has more than one activity following it, then that's a burst activity. Okay, but do next one. We mentioned some basic rules. Anyone want to answer this question? What are the basic rules to follow in developing project networks? Just find someone answer. Tarek, do you have any suggestions? The basic rules.
To prepare a chart,
Yeah, we have got few rules. Remember we mentioned. I show you the handout rules. Explain this. Oh, developing project network is like planning a road trip. You need to map out the best route, account for detour, and make sure everything flows smoothly to reach your destination on time. Okay, so this is a good explanation. So it's quite complicated things because there are a lot of crossing different nodes, different direction, different paths. So it's like you're traveling as well. You're having a car journey and you're planning your car journey, and you have to plan where you have to stop, which route you're going to take. It's similar. I think it's much complex than that, but something similar. Okay, we see next question, students. What activity on node is? A node. Ask one more question to answer, okay? Lamba, do you want to answer? What is AON?
Oh, yes, ma'am. 1 second. Ma'am, it's a project management term that refers to precedence diagramming method, which uses boxes to denote scheduled activities.
Activity on the node is just the little boxes. It is a project management term referred to the precedence diagramming method, which use boxes to denote schedule activities. Okay, remember the post-it note, the yellow notes. Those are nodes. That's just a paper to represent nodes. But in the network diagram, those boxes is a node. But each node has a lot of information in it. Okay, it's not just a box. There are contents, duration, starting, finishing time, earliest starting, earliest finishing time, etc. Connections. So this node basically is one entity representing one task that need to be finished. So it can help other tasks to be finished. So that's the node. When you are drawing a diagram or network, you will see how to put those nodes. So basically, in terms of the definition, think of a node, activity on node is a project management tool where each node represents a task, and the arrows between nodes shows the sequence of activities. It's like a roadmap guiding you through the project's path. Okay, we have one more question and we can finish for today, and then you finish the rest at home. Okay, can you answer this question? What forward pass earliest time is?
Journey.
Somebody help me. I don't know.
You don't know. No, this answer is banned. Okay.
It's banned. Okay.
Ma'am, can I answer?
You can answer. Yeah.
Thank you.
The forward pass is determined by using the earliest start for each activity and the earliest finish.
Very good. Yeah. It's EF, ES, and EF. Remember the code we used. So basically, it shows how soon activity start and how soon the activity finish, and how soon the whole activity finish.
And ma'am, the early start of an activity equals the early finish.
Oh yeah, earliest time. So sorry, forward pass is the method, one part of the method we are going to we watched in the video, and we're going to do an exercise in tutorial. We're going to use it. Okay, so forward pass is part of the activities in for identifying the critical path.
Backward pass is latest start and latest finish, right?
No, no, it's not that simple. It's finding the slack equals 0. Okay. Slack
Yes, then you will find the slack and the critical path, right? After doing the backward pass.
Yeah. So forward is only one path. We can't find the path yet. Only until you finish the backward. And if you finish the forward, you find the earliest finishing time. And if you go the backward, you find the latest starting time, and these two numbers minus each other equals 0 is what the critical activity should be. Okay, so there are three parts of the job. So you need to be quite clear which part is which in order to get the critical path.
Okay, man.
Okay, we will do an exercise and you will get some practical understanding. Okay, students, I have put into a Word document. I will email to every one of you. You can take a look, a preview at home.
Okay.
And this homework is this one. This is called the Greendale Stadium case. Okay, I will email Word and the PPT, so you can look at this case. Read this question first. This is building a stadium with a list of activities. Each has a different duration, predecessor, etc. And your task is to draw the critical path, identify the critical path. Okay, you have to draw the network first, identify the starting and finishing time, etc., and identify the critical path. Okay. It will take some time, but start from homework. But bear in mind that there is also the formative assessment from last week. You need to finish and submit to me. Okay.
Okay.
Do you have any questions, everyone?
No, ma'am.
Thank you very much for coming. I'll see you on Thursday.
Thank you for coming.
Thank
Bye.
you. Bye for now.
Bye.
Bye. Bye. Have a good evening, students.
Thank you. You too.
Thank you.
You too.
Thank you, ma'am.
Bye. Bye.
Back, 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 back.